Okay, you're good to go whenever you're ready.
Okay, I'm going. Thanks. Well, good morning. I'd like to start by a welcome of the citizens of Indiana and beyond to the Residential Wind Seminar. Welcome to Purdue on behalf of Purdue Ag Extension and the Discovery Park Energy Center, as well as the Indiana State Office of the Energy. I'll just introduce myself first and introduce the representative of the Indiana Office of Energy. I'm Klein Ilology, an assistant professor of Ag and Biological Engineering, and I'm also a renewable extension energy energy engineer. The colleague going over is my colleague Chad Martin, the renewable energy extension specialist, and he'll be the one basically interacting with you most of the day with respect to the seminar. I'd like to do a couple of checks. When you need to ask a question, you have to press the button on the microphone in front of you. So again, on behalf of the Indiana Office of the Energy, Purdue Ag Extension, and the Discovery Park Energy Center at Purdue, welcome you to the seminar. I'll introduce Mr. Travis Murphy. He's the Program Manager for Renewable Energy at the Office of Energy, Indiana Office of Energy, and he's going to introduce our speaker. Thanks again. Welcome to Purdue.
Thank you all for coming. I'd like to thank Purdue for hosting today. Before I introduce Mr. Sterling here, I just had a few notes, in particular about residential wind. Clay's going to get into a lot of details today, but I think there's a few important issues that are Indiana-centric that we need to understand. First and foremost, at this point in time, there are no grants for residential wind. We'd love to hear your input, and if there's interest out there, it's something that maybe could be generated in the future. There is, however, a property tax exemption. Essentially, the addition of your property due to the renewable energy technology that you've added will not be assessed on your taxes. You do have to apply for that, however, and you can pick that up at your county assessor's office if you get in and want to take that property tax exemption. Also, one of the key issues facing Indiana right now on the residential end is the net metering issue. And Clay will talk a little bit more in detail about that later. But as of right now, the bit of advice I would add is that early on, you work closely with your utility. You want to do this up front prior to making your decision. The issue being that cheap electricity in Indiana is essentially forcing the payback period to be longer for renewable energy products. And again, Clay will get into that a little bit more. But that's an issue that you should pay attention to, and as I said, work closely with your utility early on. And also, just a quick note, we have a wind working group. The Indiana Wind Energy Working Group meets three to five times a year in Indianapolis at the Government Center. If you go to our webpage, www.energy.in.gov, to the Technology tab and look for wind, you'll find more information about that working group. But if you care to learn more beyond what you're going to learn today, we get into also wind farms and some other issues related to wind at these meetings. Feel free to come down. It's open to the public. And with that, I will introduce our presenter for today. Let's give him a big welcome. This is Clay Sterling. He's the Education Director with the Midwest Renewable Energy Association. He has come down from Wisconsin, so let's give him an Indiana welcome.
My name is Clay Sterling. I'm with the Midwest Renewable Energy Association. We're located in central Wisconsin, Stevens Point area, which is right about in this area, straight across from Green Bay, halfway between Green Bay and the cities. We do renewable energy education. That's what we do. I'm not here to sell you anything. I'm here to get you information. My background is I grew up in a construction family, worked in my dad's plumbing shop when I was a teenager, got smart, became an electrician, worked as an electrician for about 9 years or so, and then went back to school and got a degree in outdoor education. So now I get to do both things. I work in the field and get to teach a little bit. I've been involved with about 5 or 6 wind installations, a couple of 2.5 kilowatt Provens, Little Jake, 3.6 kilowatt Jake, 20 kilowatt Jake, and a Bergie or 2. We maintain 3 of those machines. We have 3 on site. I'm involved with the maintenance of those. More on that later. And I have one in my backyard. I live off-grid. I live in an off-grid home for 10 years now, and PV. But now I'm living in the house next door, which is PV wind hybrid system. Totally off-grid, no connection to utility. We're our own utility, which has its own challenges as well. So this course here is going to be just on residential scale wind. We're talking about everything from 100 kilowatts on down to a machine that has a little 3-foot rotor. So that's going to cover a huge spectrum of stuff, something that's going to power up a sailboat to something that's going to take care of all the energy needs for a small business, perhaps, 100 kW. My goal for this class is to provide you a broad overview of the information. We could take any one of these topics that we talk about today and spend a whole semester on it, or a whole career. So we're going to have a giant buffet, and we're going to look at a little bit of everything. And I'm going to provide you with resources and information to do for the self-study, consumer education. Before you buy anything wind-related or solar electric related, or what have you, you should do your homework before you buy the product. And if possible, kick the tires, ask the questions of people that live with it before you even put any money down. It's important stuff. Too many times I've heard of people call up and it's like, yeah, I bought this dealership, now I'm going to learn about the technology. That's kind of back-ass words. And then provide you information for future workshops and future self-study. So there you go. So this is the hugest class I've ever taught, not in this scale, but we're broadcasting out to 10 other sites. So what I would like to do, I'm going to try this out for the first bit. Questions, we'll do questions at the top of the hour for 5-10 minutes, and we'll take a look at, as we go through, jot them down. And if it looks like we've got more questions than we can do in like 5 minutes or so, we'll back off and we'll do like every 45 minutes or what have you. Because we got a lot of information, we're going to stay on track, but I want to answer the questions, and questions bring in other information that I skip over or gloss over. All right? So it's going to keep me on track as well. So, top of the hour, who's going to, what's your name? Bill. Bill, you're going to keep me on track, right? You're going to give me a high side at the top of the hour, right? Let's see, what else? How many people are just here for general knowledge? Oh, very good. How many people are here for for their job? What kind of jobs are we talking about?
I'm a geothermal heating.
Okay. What else?
Natural gas utility company that's diverse into other energy sources.
Are you a provider?
Yes.
Cool. What company? Can you say? Mm-hmm.
I work for an implement dealership that is in the wind energy.
Get out.
We sell a 5 kilowatt unit from Endurance.
Mm-hmm. Very nice machine. Very good. In fact, there's a manufacturer that is an implement builder of farm implements, and then they branched off into wind. One of the finest wind machines out there. Build heavy duty. What else? What other career stuff?
I'm the Turbine County Assessor.
Uh-huh. Cool.
I work for a prison industry.
Okay. Anything else that might be...
Clay, this is Chad over here. If people have a question or comment, go ahead and push your button on that microphone, and then you can be heard throughout the other county locations as well.
Oh, yeah.
Yeah.
What else?
Could we have just a little more volume, please?
On Clay? What about tradesmen? Others?
Small business going. We have solar
Uh-huh. Where are you located at? Okay. Anything else? Anyone else? Okay. These are books, and these are books that I think you should have on your shelf, and I'll pass them around the room. And the folks that are not here, there's a list of those books right here. These are books I think you should have on your shelf. There's not a lot of wind books out there. Anything written by Paul Geip I think is worth taking a look at. He's been out there for a long time. One of the only voices out in the woods. If you have $20 in your pocket, get the Geip Light. If you got $50 in your pocket, get this one. All right? It's a little bit heavier. Geip extremely heavy. Has lots of information and good general information. It starts to get a little techie on you, but it's all right. Good bathroom reading. Pass those around. There's a madman out in Scotland, the northwest coast, Hugh Pigott. He builds homebrew wind machines and goes all around the world teaching people how to do it. Most importantly, manufacturers go to this fellow, Hugh Pigott, and they're like, okay, we got this concept of a machine. We want you to build it for you. We want you to build it for us. And so he'll work at it, and eventually come up with a design, and then the manufacturer uses that. He has developed the wind machine that this blade belongs to, the AWP 3.6, a 1 kilowatt machine, and developed for Africa. And the machine that this blade belongs to and its cousins, the Proven machines, awesome machines. So Hugh is, so the process of building a wind machine is that you take your best gas, wind the windings, put in the magnets, build a rotor for it, take a best guess at what the rotor size might be, put it up and fly it, it falls apart, you rebuild it, you put it up, test it, bring it back down, rebuild it, and this process of going back and forth of building a machine, you can't take a 1 kilowatt machine and scale it up to a 10 kilowatt or a 50 kilowatt or whatever you. It's all this back and forth process, and sometimes it just doesn't work. When I got involved with renewable energy about 10 years ago, Berge was coming out with a 50 kilowatt machine. It was all the rage. Everybody wanted one, but they're like, in 6 months' time, 6 months' time, 6 months' time. Well, they couldn't do it. They couldn't match the rotor and the generator together and make it operate correctly. And so eventually that machine just disappeared. So even the big people, even the big guys, Berge, who's been around for ages, it's not simply putting things down on paper and making it fly. It's this building it and testing period that is going to make or break the machine, and sometimes it just doesn't work. So Hugh Pigott, wealth of information, and his book, The Wind Power Workshop, has the basics of why you do what you do when building a wind machine. And this guy has built many of them. There's two guys out in Fort Collins, Colorado, 40 miles east of town, Dan Bartman and Dan Fink. They took the Hugh Pigott design, and they live out in the middle of nowhere, no utility power. Their shops and buildings are powered up by wind and solar, electric, and biodiesel. And so they took the Hugh Pigott design, tweaked it, and it's more practical. It takes advantage of low speed winds, and something that's bulletproof. So these guys are the American version of Hugh Pigott. Dan Bartman and Dan Fink. Their book just came out in December, worth however, was it $20? This book just came into our office. I haven't read it yet. Wind Energy in America, a history. Wind energy has been around since for over 2,000 years, powering up rural America since the 1920s. Just a general coffee table book, Wind Power, the Wind Power book by Jack Park, worth taking a look at. Not out of print, but you can get it on Amazon. Home Wind Power, this is a DOE publication from the 1980s. I almost chucked it out, but open up the cover, one of the best publications out there. So write down the title and the publisher, try to find it in a used bookstore. And then the last one, Power from the Wind by Putnam and Palmer. These folks were engineers out east. During World War II, they built a 1.2 megawatt wind machine, flew it, it worked, and then it fell apart. But we never saw a wind machine like of this scale until the 1990s, 50 years ahead of their time. Periodicals. The American Wind Energy Association has the wind letters, and you can go to their website and take a look at those, download all those. It's two or three pages each, worth taking a look at. Lots of stuff on zoning issues, law, birds, stuff like that. Another one out there is Home Power Magazine. This publication features a couple different systems, renewable energy systems in each issue, schematics, bill of materials, costs, things that work, things that didn't work. They evaluate equipment, but it's written so that you can understand it. And more importantly, you can go to their website and go to their archive section, put in wind energy, solar energy, what have you, and it pulls up all the past articles that they've published. Wealth of information. Now they have a new magazine out, Solar Pro, mostly for the commercial solar installer. It's free right now, so you go to this solarpro.com, get a free subscription. If you're in the trades, electrical contractors, a free publication that comes out every month. Starting to focus on and do articles on Article 690 of the National Electric Code, worth taking a look at. Solar Today, American Solar Energy Society. Now it has a magazine that's worth taking a look at. We come up with a quarterly newsletter. You can take a look at that. Call our office and get a copy, or download it on the internet. And then the last catalog or magazine I would suggest is the AWE catalog. You can go to this is a supply house in California. You can take a look at this catalog. It's $15. You can buy it. Used to be free, but you can download it, replace it every 5 years. But it has the balance of system components and solar-ready, wind-ready components that are out there, and with prices. So it's worth getting a copy of this, having it on your shelf, and then updating it every 5 years. Websites, otherpower.com. This is Dan Bartman and Dan Fink's website. Those are the folks that do the homebrew wind machines out in Colorado. They have a discussion forum on their website. What works, what doesn't work, evaluating equipment, why you're doing what you do with the different kinds of machines, this, that, and the other thing. Wealth of knowledge. Those guys are extremely smart and very practical. Dan Berman and Dan Fink. And actually, they're coming to the Energy Fair third weekend in June. Midwest Renewable Energy Association hosts an Energy Fair in Custer, Wisconsin. Those guys will be there this year, talking to people and actually building a wind machine. This is one of their wind machines right here. Scorag Wind is Hugh Piggott's website. He's the Scottish fellow. He evaluates wind machines, has a discussion board, does a lot of evaluating of equipment and the whats and whys of why wind machines are the way they are. And you can email any of these guys and get answers from them. RenewWisconsin.org. Renew Wisconsin is a nonprofit in Wisconsin who does advocacy work. But more importantly, you go into their website, and on the left-hand side is on the toolbar. It's called the Small Wind Toolbox. And then there is articles and case studies on zoning, model ordinances for municipalities, statistics and studies on bird deaths, wind calculators, this, that, and the other thing. Good place for information. The-mra.org, that's our website where I work. We have some information. And DeSeraUSA.org is a clearinghouse of information. Go into there, click on your site, and brings up all the information for your state of what programs are available, who are the contact people, net metering laws, this, that, and the other thing that relate to energy efficiency and renewable energy. And it's updated on a regular basis. Worth taking a look at as needed. A website that I use every day. Desire USA. DSIRE USA. Don't go to DIRSIR. You might be busted in some states for that. Very good website, though. Use it every day. So we're all on the same page. We're going to go through some definitions of terms. When I refer to the utility or the grid, I'm referring to the network of wires that go up and down our streets, up and down the roads, that start at the power plant and end at the outlet. And there's 3 of these grids in the United States. There's everything east of the Rockies, everything west of the Rockies, and Texas has their own because they're special. And so theoretically, you could be an electron, jump on the network here in Lafayette, go up to Canada, go over to Maine, down to Florida, over Louisiana, and back up to Indiana without touching the ground. So we have this network of wires. Now, when we create energy with a wind energy system or some sort of energy system, we have to store that energy because we're going to make tremendous amounts of energy in a small amount of time. And we may or may not be able to use that on site straight away. So we have to store it. Well, we can store it in a battery pack, which has its limitations, size, cost, and it's like a giant bathtub. We can only fill it full, and then that's it. We have to shut down the system. But if we use the utility grid as our battery, in a sense, we can put our generate electricity, put it into our home, use that on site. Any excess goes out through the utility meter, spins it backwards, stores, and we store as a credit on the utility, and then those electrons go out into wherever. And then when we need those electrons back, we just buy those credits back from the utility. So in a sense, we're using the utility as this giant battery pack that's the size of the Grand Canyon, virtually impossible to fill up. So when I refer to the grid or the utility, that's what I'm talking about. Rated output. Each machine has a rated output or a potential that it could put out. This machine here is the 900-watt Whisper. So at 27 or 28 miles per hour wind speed, that machine should put out about 900 watts. That's its potential. Now, how often are we going to have a 27 mile an hour wind? Not very often. Well, not every day. So this machine is going to run somewhere between 900 watts output and 0, 365 days a year. Now, we could think about rated output as like the speedometer of your car. My speedometer goes up to 120 miles an hour, but I don't drive 120 miles an hour all the time. I drive somewhere between 0 and 120 miles per hour. So it's the potential output. Watts is a unit of power, volts times amps, and I'm going to use that interchangeably with kilowatts. And this is just doesn't really, as it relates to wind machines, it doesn't tell us what it is doing, it's telling us what it can do. Like I say, a 900-watt machine can put out 900 watts, but not all the time. I can say a 10-kilowatt machine is the same as a 10,000-watt machine, or a 5-kilowatt machine is the same as a 5,000-watt machine. So I'm going to use those interchangeably. Kilowatt hours, that's the units that we buy and sell electricity in. Anyone know what they pay a kilowatt hour from utility? 5 to 12 cents. 5 cents, utility looks pretty good. 7? Anyone else? 7.8. Renewables have a hard time competing with cheap electricity. So there's going to be other reasons we might want to put renewables in. I've talked to people that have paid as little as 4 cents down by southern Indiana, must have been on TVA or what have you, and as high as 32 cents in Illinois from Commonwealth Edison. And I just had a lady in my class who works for Northwind, a wind company, and she's working with Alaskans who are paying up to $1 a kilowatt. It's all diesel-based generators. So when you're paying $1 a kilowatt hour, renewables look really good. So kilowatt hours is what we buy and sell electricity in, or store electricity in. So how are we going to quantify how much energy we use on a monthly basis or a yearly basis? Anyone? Get your electric bill out. Every month, the utility company sends you a bill. Then you know exactly how much you consume. So tonight, you're going to march right home, get in the door, and you're going to look at dig through the drawers and get 12 months of utility bills. And you're going to add them all up, get a grand total. That's going to be your annual load in kilowatt hours. So when we size the machine, which we'll do in a little bit, we'll take and look at our annual load. We need that number. The second number we need to know is what our wind speed is. What is our resource? What is the annual average wind speed at your location? And at what height? So if you look at the charts or at the screen, we have information. This is from our data collector from our site. This is at same longitude, same latitude, different heights. So we're at 46 feet. We have between a 4.4 and a 4.9 mile an hour wind, average annual. At 66 feet, we have 6.5 to 8.1 miles per hour. And at 86 feet, 9.8 to 11.2 miles per hour. So average annual wind speeds, same longitude, same latitude, different heights. So just by looking at those numbers, what can you say? What can you determine? Higher you go, faster the wind speed. The wind speed is your fuel. If you want more fuel, go higher. So if we look at the equation, the power equation, as it relates to wind, P, power, is equal to half the density of the air times the swept area of the rotor. Swept area of the rotor is you have 2 or 3 blades on a machine. It's how much surface area does it cover, the whole rotor disc. So if you have like a 10-foot rotor, it's the whole square footage of that it covers. Swept area. So we have power is equal to half the density of the air times swept area of the rotor times velocity of the wind cubed. All right. So if we want to get more power out of a machine, can we change we can fart around with the formula here. Can we change the density of the air? No. Can we change the swept area of the rotor? Sometimes, with consequences. More on that later. Can we change the velocity of the wind? Or can we? We can increase the velocity of the wind if we go higher. What if we have a 8 mile an hour wind? It'd be 8 times 8 times 8. What is that? 512, I believe. Versus going to a wind that's 10 times 10 times 10. What's that? 1,000. So by increasing by 2 miles per hour, just 2 miles per hour, we can get 1,000 more units of energy out of it. Or, I'm sorry, double our energy that's in the wind. So if we can just put on, it's far cheaper to add on tower sections than it is to size for a larger machine. So in a sense, if we can get even higher, we can reduce the size of the machine, reduce the cost of the system by adding more tower sections on. All right? Getting into the fuel. Fuel's not down here where we live. Fuel's up high. In Wisconsin, entry-level tower used to be 80 feet. Then it went to 100 feet. And then the Focus on Energy program kicked in. The state incentive program came. and that's production based. If you want reimbursement from the state to buy down the cost of your system, then you have to produce more energy. What's the easiest way to produce more energy? Taller tower. So now we're seeing 120 feet, 140, 160 foot towers, because that's where the fuel is. Same machine, more energy. So I'm going to give you some resources on how to find or where to find the wind speed for your longitude and latitude and at a given height. So I'll give you that information that you can do your research. Net metering. All investor-owned utilities in the United States are required by federal law to allow you to hook up to their system and store energy on their system at a rate that's equal to what you pay. So we're going to buy electricity at, say, 10 cents a kilowatt hour. We're going to generate electricity and store the excess energy on the investor-owned utility at the same rate, 10 cents. So we're going to have this equal exchange. However, co-ops, REAs are not required to do that. Municipalities may not be required to do that. And it varies from state to state. Now, that's federal law, and now each state is different. Now each state is going to say is going to limit your production based upon capacity. You know, what is the potential capacity of a wind machine or your system or systems? And in some cases, they're going to limit your production on an annual basis. You can maybe only do a certain percentage over your annual use. But in general, it's going to be based upon rating, output rating. Indiana is limited to 10 kilowatts of something, a 10 kilowatt wind machine, 10 kilowatts of solar, or a combination of the above. But once you get up to 10 kilowatts, you fall into net metering law. Once you go over 10 kilowatts of capacity, rated capacity, that says nothing about what you can produce, rated capacity. Remember, this machine's rated capacity is what? 900 watts. Doesn't tell us what it's going to produce, just over a period of time, just a nameplate rating. So in Indiana, you can go up to 10 kilowatts. Once you go over that, then you fall in a different category where you're going to buy electricity at, say, 10 cents, and then you're going to store at wholesale rates, maybe 2 cents, 3 cents. Not a good deal. So you want to stay at or below those caps. Something we've been doing in Wisconsin is, and nobody said we can't do it yet, is we're limited to 20 kilowatts of production. So here's an example. We have a 20 kilowatt Jacobs wind machine on 1 meter, and that's all we can put on it, 20 kilowatts. So that meter's filled up. Over at our office building, we have 3.6 kilowatt Jake, 2.5 kilowatt proven, 1.2 kilowatts of PV. Actually, I think I have the laundry list here. And about another kilowatt of PV on that meter. So if you add that all up, I think that comes up to about 8 kilowatts of something. And we can fill it up with another 11 kilowatts of something. That meter's done then. And then on the site, we also have 3 more meters that we could fill up. We can fill another meter up with a 20 kilowatts, fill up the other 2 remaining meters with 20 kilowatts each as well. So once we fill that meter up, we're done. We have to move to the next one, the next one, and the next one. Once in a while, there's different ways to skin a cat. How are we doing? Questions? Good?
Can you add a second meter and split between two? You can't have one windmill powering back into 2 meters.
No. No, you can't have one wind machine feeding into 2 meters. No, not doable. You can't have one machine feeding 2 households. That would be essentially 2 meters as well. You can't have a shared one. You'd have to have a central power source, power system. Short history on wind. This section is about, I throw in there to get you to think about wind energy. This isn't new. There's nothing new about this. This is over 2,000 years old, been around for ages. And we'll see some of these designs, over 2,000 years old, come back again and again and again into the conversation. Back in BC times, the Persians took a vertical shaft, put reed bundles around it, wind pushed on one side of the rotor, pulled the other side of the rotor through the wind, and they were able to grind grain. Slow-moving machine, did a really good job of grinding grain and pumping water. Great for what it was meant for. Over 2,000 years old. The European Crusaders came down from Europe, saw that technology and took it back to Europe, moved it into a horizontal axis, and they used it for the same purposes, grinding grain, pumping water, irrigation. But then they took in, on the house, the top of the tower, there was, they had to rotate that around. So you'll see there's a pole coming off the backside that's a tadpole. You and 6 of your friends would grab onto that pole and orient the rotor into the wind. And then eventually they put a huge giant bull gear up on top and a smaller rotor. Then the smaller rotor would automatically rotate the rotor, big rotor, into the wind. And this is 1200, 1300 AD. These guys had their act together. Very simple technology. The simplest machines are the ones that are going to last the longest. Fast forward to the American West. Americans were pushing out into the Western Plains, and they had two things that needed water. They had the steam locomotive, which needed water, and cattle. Where was the water? The water was down deep. Thus the deep water pumping system. Millions of these were sold. Still can buy them today. And that's what allowed us to move west, expand out to the west. Fast forward to World War I. Most of the United States was rural. Most of the rural United States had no power lines going out to them. And the soldiers went out to Europe to fight the war, saw the lights of Paris, and wanted that technology back home. And at the same time, the automobile came out, which had a generator, the airplane, which had a prop, and the battery-powered radio, which allowed you to have contact with the outside world. So the soldiers came back home, started messing around with what was available. So they put a generator on a water pumper, produced a little bit of energy, powered up a battery. Then they put a prop from an airplane onto a generator and produced tremendous amounts of energy. Then they had something. So then they took and developed this, people developed this system and powered up rural America. Many farms in the United States were powered up by wind power in the 1920s, 30s, 40s, and 50s. And you buy a wind machine, great big giant battery pack, DC appliances for the farm, for the barn, and for the home. And this is bulletproof engineering, very simple, very straightforward and practical engineering. And I actually paid more for this brochure than that wind machine cost originally. Just absolutely brilliant. So after World War II, when rural electrification really kicked in, there was lots of materials, lots of labor around. That's when the grid was strung out into the rural areas. And part of the deal was you could hook up to this new technology for free, but you had to take your wind system out of service. So most of the wind machines, they just unbolted it from the tower and just tipped it over the side. This is the Jacobs wind machine, the long case, originally built in Prior Lake, Minnesota by the Jacobs boys, Marcellus and the other one. And this is the benchmark of all wind machines today. Very simple, heavy-duty, slow RPM machines which produce lots and lots of energy. This machine was built originally in 1942, and the one behind our office, there's a 100-foot tower with a machine just like it on the tower, originally built in 1948, still putting out energy. I know a guy who has one built in 1941. You can't get these, they don't manufacture these anymore, but you can still get them. Guy that has the 1941 machine, bearings froze up, got in there, pulled the covers off, sprayed lubricant into the bearings, rocked the rotor, broke it free, forced grease into the bearing. It's still running on the original bearings from 1941. Just bulletproof machines. But this is the benchmark for all machines that are out there now. Back in the 1970s, 1980s, there was over 70 different wind manufacturers in the United States. Now there's 5 in the United States. And those machines are the ones that are based upon the simplicity of the Jacobs machines. This is Putnam's machine that he and those guys built in the 1940s, 1.2 megawatt machine, two-bladed machine, metal blades. What happens when you move metal back and forth? It hardens up, fatigues, and breaks off. Well, that's what happened. Each blade is 8 tons, and metal blades work back and forth. Blade flies off. There was a metal shortage, so they couldn't get enough metal to fabricate a blade till after the war. Remanufactured a blade, put it on, and then the other one broke off. And then they just abandoned the site. But we never saw a machine of this size or caliber until the 1990s. They were way ahead of their time. And now we have the modern wind machine. One big generator up in the house. Clipper Wind in Iowa just came out with this design 2 years ago-ish. Instead of one giant generator up in the top, they have 4 small generators in the house. And if one fails, they can take it out and put a new one in. But the whole machine isn't shut down. New idea, a better mousetrap. For the purpose of this discussion, we're going to limit our discussion to machines that are 100 kilowatts and less. So we're talking about rotor diameters of 3 feet all the way up to 60 feet. So that's a huge broad range. We're going to take that range of 3-foot rotors to 60-foot rotors. We're going to break them up into smaller, more manageable sections, units. We're going to talk about cabin charging machines, whole home machines, and then like small commercial type machines. So we're going to break this up more manageable sections. Why 100 kilowatts? Well, there had to be a line somewhere. And the North American Board of Certified Energy Practitioners, blah, determined that 100 kilowatts on down is going to be considered small wind. So NABCEP, if you want more information, go to nabcep.org. And this is a nonprofit based in New York, and they administer certification for solar electric installers, solar water installers. Now they're working on wind electric installers as well. They just got done with the criteria for what you need to know or what you need to have for background to sit for the test. Now they have to develop a test. And that's going to probably take a year and a half's time. And so we won't see a certification for installers probably for 2 years maybe. nabcep.org if you want more information on that. Actually, this chart is outdated now. Used to be for these categories of rotors. We're looking at rotor size relative to a human. We're talking about machines with a 3-foot rotor up to now not 30-foot rotor, but 60 feet. Why the change? Well, there's more machines coming in from different places. PGE is coming in from Canada. Those machines have 50, 60-foot rotors. The Northwind has a 60-foot rotor. Wasn't available before. Is coming into the United States and is available now. I think one of the first installations is going to be in the Midwest. A bunch up in Alaska currently. So we have new players coming in from Europe and Canada. Machines that we didn't have available to us. Why? Well, these are bigger machines, and dollar per watt to install them is far cheaper dollar per watt to install a big machine than it is a small machine. And this has all changed quite rapidly in the last 3 months, 6 months. Basic parts of a wind machine. The collection of the blades is the rotor, and maybe 2 blades or 3 blades. So the combination of those 3 blades or 2 blades is going to make the rotor. And the rotor is going to have a swept area. How do we determine the surface, the square footage of a circle? pi r squared. So that whole area is our swept area, our working area. All right. Right behind the rotor is the generator in general, and it's going to be a collection of magnets running over a group of copper coils. In general, we're talking in general. In general, there's going to be a tail that's going to orient the rotor into the wind, keeping it, the blades perpendicular to the wind. In general, there's going to be a tail. And then a tower to hold all this mess up in the air. Hugh Pigott, and this is from Hugh Pigott's book, The Wind Power Workshop, which is passing around. And when you're in a conversation with Dan Bartman, who also talks in these terms, Dan says you can determine everything about a machine by its rotor diameter. Rotor diameter is everything about that machine. Why? That's your collector. You don't have a big enough collector, you're not going to get fuel to turn that alternator, that generator. So he doesn't talk about 90 watt or 900 watt machines or 1500 watt machines or 10 kilowatt machines. He talks about rotor diameter. And he'll say, he's like, like you'll say, yeah, did you hear about the new 10 kilowatt air? He's like, no. What size rotor is on that? And you'll tell him, he's like, oh, yeah, that sounds cool. Yeah, I understand. So he's saying to me, well, he doesn't care what the rated output is. What's going to tell him what that machine can put out is the rotor diameter, because that's where it's all at. And if you look at Pigott's chart, he says that at 10 miles per hour wind speed, doesn't matter what height, we're just talking a 10 mile an hour wind speed, that a 3-foot rotor should put out about 13 watts, 10-foot rotor should put out about 115 watts, a 13-foot rotor should put out about 204 watts, and so on and so on and so on. So at the same wind speed, the larger the rotor, the more surface area there is, the more you can harvest out of that wind. All right? And there's going to be strategies that manufacturers do to get more energy. And if we double the diameter of the rotor, we're going to get 4 times the output of the machine. Why? Well, pi r squared. If we go from a 10-foot rotor, pi r squared, we have 78.5 square feet. We double that rotor size to a 20-foot rotor. The square footage is 314 square foot, or 4 times the surface area, the swept area. And if we have 4 times the swept area, we're going to have 4 times the output. This chart is from Ian Wifferden's article in Home Power. Oh, by the way, an added bonus feature to this publication that you have in front of you. I pulled out all the good wind articles I feel that relate to different subjects are right behind each section of PowerPoint, and there's like 3 or 4 in each section. I think this is one of them. So in this chart, they're saying the blue line, the big bell-shaped blue line, that's the frequencies of wind. So we have more frequent winds from about 7 miles per hour to about 12 miles per hour than all the others. The light winds, not very much. The heavy winds, not very much. So our wind machine has to live and work in the 7 to 12 mile an hour wind speed range. That's where our most frequent winds are. Yeah, we're going to have more heavy winds. Yeah, we're going to do that. But we're going to have more of the lighter winds that we have to deal with. So if rotor diameter is everything about output, let's talk about this. So here's a blade off a 900 watt African wind power. This blade is off the 900 watt Whisper, this machine right there. Which machine is going to produce more energy? Which blade? This one. Why? Because it has the largest swept area. So we now have 2 machines rated at the same output with different rotor sizes. So this machine, which is going to put out more energy on an annual basis because of these lighter winds that we have, these mediocre winds, it's going to have more production in those winds than this machine right here. All right. So what the manufacturer or the designer, Hugh Pigott, says is, I want to get more production off this machine. So it's operating in lighter, mediocre winds. I want to take advantage of that, oversize the rotor. More on this this machine right here. African wind power, developed by Hugh Pigott for the for Zimbabwe, to be operated in the country of Zimbabwe. And what do we know about Zimbabwe? Southern Africa. And what can we assume about the temperatures? Warm or hot. So when we have warm or hot air, what does that do to the air molecules? Further apart, closer together, it doesn't matter. Further apart. So we have less dense air. So not only are we operating in lower winds, we have less dense air. So he oversized the rotor to take advantage, get these low winds, and they did battery charging in villages. So fast forward. So this machine, very successful in Africa, imported into the upper Midwest by a couple of dealers. So now we have this wind machine that's supposed to operate in light to mediocre winds, hot climates. We take it up to the Midwest. What kind of air density could you assume from that? Dense air. So now we have a machine rated at 900 watts, but really puts out 1,200 watts. And in all practicality, probably closer to 1,800 watts. So now we have a machine that's just oversized rotor, just killer performance out here in the upper Midwest. Why? Because it has a larger rotor. Here's some of the outputs of, or the rated output of various machines and at what wind speed. So like the Whisper 100, that machine will reach 900 watts output at about 28 miles an hour. The Berge 10 kilowatt, the XL, it's going to put out 10 kilowatts of energy at about 31 miles per hour, and so on and so forth. Oh yeah. So that's where the rated outputs are taking place. But if we look at this chart, here's where those numbers are taking place. Those numbers don't happen. These wind speeds aren't as frequent as these mediocre wind speeds. This is where the wind machine is going to be living most of the time. This chart here is out of a larger article called Apples and Oranges, which I highly suggest that you go home, march home tonight, and go to homepowermagazine.com, go into their archives and pull up the Apples and Oranges article. It's about 70 pages long. This chart is from that. So the author from that article, which was made in 2002, last updated in 2002, and there's a later version of that in the back of this section called Wind Turbine Buyer's Guide, where they evaluate wind machines. Also, is a later version. So they took all the wind machines at that time that were available at that time, and here's the average annual wind speeds, what the manufacturer says that machine should produce at those average annual wind speeds, and then mathematically the authors calculated out what those machines should do mathematically, and then the difference. Huge difference. So the manufacturer is telling you one thing, and reality is a different thing. So we have Disneyland and reality. So unlike solar electric and solar hot water, there's no third-party testing of wind machines. So whatever a manufacturer says, you got to take it with a grain of salt. It could be true, it could not be true. The only one that was accurate was the African wind power. Why is that accurate? Well, they have an oversized rotor on that machine. Up until now, just incorporated last February, a year ago February, is the Small Wind Certification Council. You can go to their website. They're not up and going yet, but they're going to provide independent third-party testing of all wind machines in the United States based upon European standards. There was this bickering back and forth of how machines were going to be tested and what have you. And they just said, well, we're just going to do European standards. We're not going to test the Berge standards. We're not going to test the Southwest Wind Power standards. We'll do European standards. So just like when you buy a refrigerator or a hot water heater, you're going to have a sticker on the wind machine, and that's going to tell you four things. It's going to tell you what is the peak output of the machine, the kilowatt hours production at various wind speeds, and these will be tested. some sort of reliability rating, and then sound rating at X amount of feet away from it. So those 4 things will be on that sticker. Third-party verified. So now we're not going to have a manufacturer telling you one thing and reality being another thing. So we're going to have some sort of third party involved into the system. Small Wind Certification Council. I just got onto their website, and I think it is smallwindcertification.org. Google it up. And then you can get it on their mailing list, put in your email, get on their mailing list, and you can get regular updates. Okay, questions?
I was just wondering if you could repeat that website.
Oh, yeah, okay. What else? Other questions? Yeah.
The theories that you were giving about the size of your wind collection, where you take like the diameter of your rotor and the size of that equal, what was it? I don't remember. Does the same theory apply to vertical axis machines as compared to horizontal?
Oh yeah. So does the swept area of a rotor disc, is that similar to a swept area on a vertical axis machine? Yep, absolutely. So you would figure out the swept area of a vertical machine as well. And they have a square footage, and that would be just length times width, because the wind is going to see a rectangle in the air. Now, some of those rotors, not all rotors, some of those rotors, the drag rotors, the Sylvonius rotors, are going to be only half of that rotor is going to be working at any one time. Now, there's other vertical axis machines that have an airfoil that go around, kind of like similar to these blades, an airfoil, true airfoil, and they're going to be configured in a way so that they're operating most of the time. So you're going to see most of that swept area being used. Not all of it, most of it. Another question.
Yeah, where was the article on the apples and oranges article?
Go to homepower.com and go into the archives and pull up the apples and oranges. It's also on the renewwisconsin.org website as well. It's about 70 pages long. Lots of good information, though. And most of those machines are still available in the United States. Yes?
Feel free to tell me you'll get to this, but with the net metering, is it possible to use the grid as your battery up until the 10 kilowatt and then have your own batteries start taking in the extra?
Can you have more than 10 kilowatts of rated capacity and tie to the grid? No. You wouldn't fall under net metering anymore. So once you go over the 10 kilowatt rated output, you would fall in a different classification, and you would buy electricity at one rate and sell at a lower rate, or store at a lower rate. But you wouldn't be able to put in, if you want to incorporate batteries with a larger system, you still wouldn't be able to grid tie, because it's all based upon rated output, not production based. Does that make sense? Yes. But we can use the utility as a backup source, and we'll talk about that later when we incorporate some batteries. Bring that question back up again as it relates to batteries. Mm-hmm.
Could you repeat the 4 sticker criteria?
Oh, yeah. So the Small Wind Certification Council, and actually Brent Somerville is going to be running this project, smart guy out in Appalachia State. Peak output, kilowatt hour production at various wind speeds, some sort of reliability rating, and then sound rating at so many feet away, or feet. And, something that's going to make or break wind, and get this all the time from people that aren't familiar with the wind, they want to know about wind, is how loud is that machine. So there's some sort of preconceived notion out there that wind is loud, and that from back in the old days, Carter era tax credit machines, loud machines. You can't have a loud machine these days. It's just not acceptable. And we have to live with the neighbors as well, right? We have to deal with them. So wind machines should be seen and not heard. Other questions? Yes.
I've got a question. I'm in Columbus, Indiana.
Uh-huh. Go ahead. Oops. We can't hear you.
Okay. Can you hear this?
Yep. Can't hear you.
Can you hear now?
Yep. Try that.
Can you hear Hendricks County?
Yep.
Okay.
Okay. Question. Can these wind turbines be manifolded from a multiple number of these turbines into a battery system through a voltage control setup so that you can have not only just one but 3 or 4 feeding your system and not going into your grid system?
Oh, sure. Yeah, you can. So even whether it be multiple wind machines or incorporating solar electric, yeah, we can feed into one big battery pack if that's what you want to do. There was a lot of Y2K systems out there, and shortly I'll show you what kind of system I have in my backyard, which has a wind machine feeding 2 battery packs. Another question? Yes?
That Indiana 10 kilowatt. Oh, excuse me. That Indiana 10 kilowatt, is that just the manufacturer's rating? So then you could play with those things to maybe
No,
get more?
it's all based upon rated output. Whatever the manufacturer says that machine will put out, that's what you're...
Clay, could you repeat the question?
Oh, the question is, as it relates to Indiana, Indiana's rated capacity output, the max you can put online is 10 kilowatts. Now, is that, can you say that again?
This table chart, you were showing wind turbine parts, the collector and stuff. It seems that the ratings were different. The real ratings were different than what the manufacturer rated it at. So I wondered if they worry about the real rating or the manufacturer's rating.
They're going to talk, the utility is going to be concerned about manufacturer's rated output. That's what they're going to go on, nameplate rating. And now, if we look at 2 different machines, the ARE 442, a 10 kilowatt machine, and the Burr EXL 10 kilowatt machine, same thing, same rated outputs, but the ARE puts out almost double the output, and the utilities, whatever. But if you're looking at output and you want to get maximum amount of energy out onto the grid or into your home, you're better off buying the machine that puts out the most energy. ARE 442, same rated outputs, but double the production. Has a larger rotor. Okay, one more question?
How are they going to control that small wind certification to where they're actually rating it at the maximum? In like our area, we're in a class 2 wind area. Are they going to classify that for certain areas? Because if you're classifying it in Texas where they've got a class 4 or 5, and you bring that unit and bring it here, well then that's going to throw us way over and it's not going to produce enough electricity.
I don't know how they're testing. You can go check out their website.
Okay.
Yep. Go to their website and check out and see how they're doing it.
Well, you see what I'm talking about, don't you? As far as rating the unit in a different area, different classifications. Because we're in a 10 to 12 mile an hour classification here.
Yep.
So are they going to rate the units in the areas for the classifications?
Well, it sounds to me as though they're rating it by wind speeds, various wind speeds.
Okay.
So at this wind speed, just like on this chart, at this wind speed, say 12 miles an hour, this machine will put out this amount of energy.
Right.
Or at this wind speed, it's going to put out this amount of energy. But it's been verified. It's not mathematics. It's not a manufacturer. It's been verified through testing. But I don't know what those procedures are. But you can go into the website and check out the procedures.
Okay, thank you.
Yeah, and Brent Somerville's been doing this for Appalachian State for several years now.
Thank you.
Yep.
I've got a 2-part question. Phase control on your generator and your wind farm, and your power on the electric lines. How do they control your phase control on that? Match phases.
That's coming up. Yep. One more. Okay.
You said
You said if you use the African wind power machine in Wisconsin, it produces much more than its rated nameplate rating. Won't that burn it up?
It could. Without regulation on that, governing the output of that machine, there could be problems with that. Yep. And we'll talk about that machine. It's a sloppily built machine. It's sloppily meaning the clearances and tolerances are real crude. And we'll see another machine that's a spin-off of that. More on that in just a little bit. Okay. So yes, we're going to have to control the output of that machine in some fashion so that it doesn't burn itself out. Yep, absolutely. Do we have to take a break? Where's that tech guy?
Yes, we need to break between the segments.
Okay. How long a break?
Just a couple minutes.
Okay. Do you need 5 minutes or less?
It's up to you.
Okay. Let's take 5 minutes, eh?